Good morning, everyone. Thanks for joining us here again for another webinar series presented by DTE and Consumers Energy. We are going to just give it a minute or so to allow folks to roll on in, and then we'll go ahead and get going with the presentation for the day. Okay, seeing folks roll in, I feel like we're at a pretty good point where we can go ahead and get started with today's presentation. Again, I'm Chris McTaggart, for those who have not previously joined this webinar series. And so, the title of the series is Building Smart Energy Efficiency Essentials for Modern Homes. And this is an ongoing webinar series sponsored by DTE and Consumers Energy that is really intended to up all of our games here in the residential new construction industry to understand how we can make homes here in the state of Michigan better through energy efficiency and building science practices, leveraging the DTE and consumers new homes programs that focus on above code programs. So today's session is on optimizing building performance with HERS ratings. So we're going to go ahead and roll on into this. For those who haven't had the experience, the Resonant HERS Index is an asset rating score that helps to depict the energy efficiency of a home. And there's a whole standards-based process with professionals that are credentialed to conduct evaluations, both software analysis as well as field inspections and testing, to then quantify the energy efficiency of a home using the HERS index. So we'll go over what exactly the HERS index is for those who haven't had the experience with it, and then talking about how can we use that HERS index in order to strategize for improving our building. And there's certainly a cost versus benefit that goes into this, but using the HERS index, the cool thing about HERS is that it is extremely flexible. It gives builders the opportunity to invest in energy efficiency any way that they see fit. It doesn't specify mandatory elements for a home to be energy efficient. A builder can really take a variety of different paths in order to achieve a good HERS score to deliver an energy efficient home for their customers. And so there's a lot of value to that process. And so we're going to go into exactly how you can use the HERS index to give your consumers a better home. Again, I'm Chris McTaggart. I'm the president of Building Efficiency Resources. For those who have not previously taken this webinar series, my company is a national quality assurance and training organization within the residential energy efficiency industry. We work with about 500 certified ResNet professionals all around the country, including several here in the state of Michigan. I myself am based in Detroit. I grew up in Metro Detroit, went to Michigan State, and don't hate me if you're a Blue fan, but I'm homegrown. I'm from the state, raised and went to college here, and got my career started out of state, but came back in order to raise my family here in the place that I love dearly. I don't just know Detroit. I am a big fan of and pretty familiar with what's going on in the west part of the state and up north in the northern lower peninsula, as well as kind of how things get built up in the upper peninsula as well. So I've been just about to every corner of the state and a big fan of my home state of Michigan. So jumping into the ResNet HERS Index, First of all, why are we even talking about energy efficiency? And I think nowadays we especially have to ask ourselves that. And I would just challenge and say, no matter what the rhetoric and subterfuge is out there, nationally, energy efficiency is more critical than ever before. Why? Well, because ultimately, the majority of the energy produced in this country comes from sources that do produce a degree of pollution, be it air pollution, water pollution, etc., soil pollution. And, obviously for our own health as humans, as well as the health of ecosystems, producing less pollution is not a bad thing. I think we should all be able to agree that that's not the worst thing in the world. Um, Beyond that, the grid, think about how much we're hearing about artificial intelligence and, we're using more power than ever before. Well, guess what? That's kind of expensive to build out at a national scale and then to maintain. When you have huge energy demands, somebody has to pay to create all that infrastructure to ensure that the lights stay on. And that ends up usually being consumers, and we pay for it through utility bills. And, our energy bills across the country and here in the state of Michigan have been going up, and for good reason. The utilities are investing in the state of Michigan. They're investing in cleaner sources of energy. They're investing in resiliency of the grid to make sure that our power is more stable. And in that basically Michigan is going to be set up for success from a business and living standpoint for many decades to come. Any piece of infrastructure that you have, you want something, you got to pay for it. There's an infrastructural cost, but it does reflect in energy bills. So I think that this topic is extremely timely of energy efficiency because people have rising costs. Cost of living are going up, and utilities are not the biggest part of it, but they're part of it. And so why not consider energy efficient building? Because it reduces operational costs for the end user. And by reducing that operational cost, it also stresses out the grid less. So we maybe don't need quite so much infrastructure, which is costly, or we don't run the risk of blackouts. And then we can also basically save more, pollution. Basically we're going to reduce pollution, and you can take that pollution and however you want to quantify it. Some people are extremely concerned about climate change, other people not so much. That's your choice to feel the way you want to about it. But when you burn fossil fuels, when you burn coal, when you burn natural gas, when you burn other fuels, there are gases that are emitted and particulate matter that maybe I don't want to drink or breathe that in quite so much. And so energy efficiency has an opportunity to reduce costs, which then have trickle down benefits to everybody. It just so happens that energy efficient homes tend to be more comfortable, and they have the potential for significantly better indoor air quality. Why are they potentially more comfortable? Well, because if you optimize the building enclosure, so the air tightness system and insulation system of a home, people can be more comfortable. We are able to stay more comfortable in our homes no matter what the temperature is outdoors. Also, there's things like less drafts. We don't have, when we have more airtight homes, we don't have drafty conditions that make us feel chilly. When you optimize HVAC systems and ideally test those systems, then they're going to be, proven to be operating at their optimal performance, not just thrown in. And, in terms of indoor air quality, again, think about this summer here in Michigan. We had Canadian wildfire smoke. There's nothing, no matter where you live, didn't matter if you lived in Detroit or if you lived in Fenton, or if you lived in Grand Rapids, or if you lived in Clare or in Traverse City or anywhere in the state. Didn't matter if you lived in the rural area or an urban area. We were all subject to Canadian wildfire smoke, including in our own homes. And why that is because when buildings leak, when they're allowed to breathe, then basically whatever the air is outside is inside. So one huge benefit that I think that people need to pick up on here is when we button up these homes and make them more airtight and then have controlled, filtered mechanical ventilation, there's a huge opportunity to basically make the air quality better in a home. So huge benefit here. Also think about stuff like humidity. It was a really humid summer. Guess what? If it's humid outdoors and we have a leaky home, it's going to be humid indoors. So there's a lot of benefits to energy efficient homes. And then, long-term value appreciation. Here's the deal. If you're saving money on your bills, you're able to take that money and do other things with it. You're able to make investments for you and your family. And that could be just enjoying life. It could be paying down debt. It could be making investments that pay themselves off in the long run. Furthermore, when you invest in energy efficiency, you have the ability for that to be valued as part of the mortgage and appraisal system so that your home can be basically qualified for a larger mortgage from whoever the buyer might be. Plus your home ends up looking more updated by the result of having invested in energy efficiency. So there's a lot of benefits that go into energy efficiency that aren't just about pollution. The HERS index is a standardized scoring methodology that can be used to depict a home's energy efficiency. It is promulgated by the Residential Energy Services Network, or ResNet. ResNet is a longstanding 30-plus-year-old organization that is a nonprofit focused on promoting energy efficient buildings, and in particular residential homes. And the HERS index is its main product. The HERS index is what we call an asset rating, meaning that it is a score that can be applied to the home in order to functionally describe how we believe it should perform relative to a standard reference case. Meaning it's not an operational energy efficiency metric. We're not actually looking at people's bills in order to determine what the energy performance is, but rather we're comparing the as-built home to a standard reference home that is equivalent to a home that meets the 2006 IECC and with federal minimum equipment of that era. So about a 20-year-old sort of worst you could build type of home from the 2006 IECC. The way that this scale works is that every point reduction on the HERS index from 100, 100 is the baseline, that's the reference home. Every point reduction is 1% energy savings versus that reference home. So here in our scale, we see a 65 on the HERS index. That would be 35% more efficient than that standard reference design. So pretty cool how that works. We can get all the way down to 0 or even negative HERS index scores for customers who build an energy efficient home that then has on-site power production sufficient to offset most or all of the energy that's used on site. And that would be what we would typically refer to as a net zero energy home. So you can use this on new construction. You can model a pre and post renovation on a home, or you could even do it to an existing home. I live in a home built in the 1920s. I can score my home on the ResNet HERS index. And every time that I make an improvement, I can remodel that home in order to demonstrate an updated index score. It's kind of cool in that regard. If I were to be, when I originally bought this home, 1927 home, it definitely scored over 100 on the HERS index, which would mean that it would be below average. Why? Well, because it was built in 1927, had all original single pane windows, It was extremely leaky, and I didn't have a stitch of insulation in it. And my mechanical systems weren't very good. So I kind of didn't really have anything that great going for me. But over time, I've made improvements. I've insulated my home. I've replaced the windows. I've made my home more airtight, and I've improved the mechanical systems over time. And so my home scores much better on the HERS index now today than it did certainly when I bought it. We're not really talking about the application to existing homes quite so much today. We're really talking about new construction, but it works for any home. Again, the reference home is essentially equivalent to a 2006 IECC era home. You know, for existing buildings, a study was done many moons ago that said that the average HERS index in America was a 130 for existing homes. That really, it depends on where you are, though, because I'll be honest, here in Detroit, where we have such old homes, the average age of homes in the city of Detroit is probably like 1950, because we just have, turn of the 20th century homes, and a huge glut of them that were built in the 19 teens and 1920s and 1930s. Guess what? That was before insulation was a standard feature. That was before energy efficiency was really considered, or certainly not before we had energy codes. So here in Detroit, I'd probably say that the average is probably closer to like a 150 or 160. So, take that with somewhat of a grain of salt. But the point is that oftentimes that existing homes might score above 130 if they haven't been invested in. I've already kind of described how this works. A HERS 60 would be 40% more efficient than the reference home. So again, typical older home, depends on where you are, but we would say 130, 150 could very well be the case. The reference home is at 100. The Energy Star version 3.1 program, which is, if you're going to certify to Energy Star in the state of Michigan today, you have to certify to at least version 3.1. That's going to score somewhere in the 55 to 65 realm, most likely. If you want to go for version 3.2, which is the minimum standard for achieving compliance with the 45L tax credit, then you're going to be in the 45 to 55 range, and the same goes for version 3.3, which is very similar to 3.2. Zero Energy Ready Home, which is through the Department of Energy, that's going to score someplace likely in the 40s. Passive house certification, be it FIAS or PHI, those are going to score probably somewhere in the 30s to 40s. And then a net zero is going to be right around zero. Sometimes you're a couple, potential points above zero, and you might actually still get zero bills at the end of the day. Ultimately, we use estimates of on-site power production, and we also use estimates of how we believe that the occupants will use the home. So a lot comes down to exactly what's happening in real time, but somewhere there in the plus to minus 10 realm, you're going to hopefully be in the case for a net zero home. In 2024, it was a banner year for the resident HERS index. Almost 440,000 homes rated all around the country with an average HERS score of 55. In Michigan, we were about 5,000 of those homes, and with an average score of 59. Interestingly enough, in order to participate in Consumers Energy's new homes program, you have to score a 59. So good news is that the average HERS home getting rated in Michigan is good to go to participate in the Consumers program. So how the HERS index is calculated, there's a standardized calculation procedure, the ANSI Resnet ICC 301 standard. I'd say most homes that were already permitted are going to wrap up under this 2019 version. There's actually a 2022 version of the standard that is also live now for any brand new homes getting permitted. Like any other code or standard, the 301 standard gets updated on a regular schedule once every 3 years. And so the 301 standard sets those specifications for the rated home and the reference home and all the calculation procedures. So there's a lot of nerdy physics calculations that are in this standard, as well as just descriptions of if the reference home has this, then the rated home shall have this type of scenario. And there's a lot that goes into it. Ultimately, what the HERS index is looking at is energy loads and consumption for heating, cooling, water heating, lights and appliances, and on-site power production. So all the standardized elements of a home that consume energy. There are assumptions that are made, again, about occupant behavior based off of the number of bedrooms. There's an assumption of how many people might live in that home. And then there's a certain like per square footage or per person allotment of how many computers are being charged, how much television is being watched, how many cell phones are being charged, how many people are playing guitars or other playing video game systems, other stuff that maybe uses energy. That's just called miscellaneous energy loads. There's a lot that it's just an assumption because we don't know how people are going to use a home. You could have 6 people living in a 3-bedroom house, or you could have one person living in a 3-bedroom house. So occupant behavior is difficult to depict, so there are assumptions made there. But otherwise, there's sort of standardized calculation methods for dealing with heating, cooling, water heating, lights and appliances, and then again, on-site power production, which would be things like solar panels or possibly even wind production. The main software programs that are used are Ecotrope, REMrate, and then Energy Gauge. In particular, if you're participating in DTE and consumers rebate programs, Ecotrope is the main calculation engine used by the implementers. You could use another ResNet software, but they would basically have to get the export so they could convert it into Ecotrope. All these energy consuming elements, we call them minimum rated features. So mechanical equipment, that would be like your heating and cooling and water heating equipment. Then we think about their distribution system features. So here in Michigan, most people put in ducted heating and cooling system. And so we have to characterize the ducts. Where are they located? Are they in conditioned space or are they in an unconditioned space like an attic? Then they're oftentimes tested by the rater in order to figure out how airtight are those ducts. Are they able to move their conditioned air around the home? And the same thing goes for water heating systems. Some people may elect to put in recirculation systems on their hot water systems. You can get credit for good design or less good design within the HERS index system. Performance testing. We, in the residential energy efficiency rating industry, we test homes for infiltration. That's how airtight the home is. We'll also test the duct leakage. Basically, how tight are those ducts so they can efficiently convey heated and cooled energy around the home. Most new homes have mechanical ventilation systems that are meant to promote better air quality in homes. Those, again, are a minimum rated feature, and they have to be tested. We have to figure out what type of system. Does it have controls? Is it an exhaust-based system, a supply-based system, or a balanced system? And then we measure the airflow as well as potentially the fan wattage for what that system is performing at. A relatively new element of the HERS standard is HVAC rating. That is basically looking at the installed heating and cooling equipment and determining was it designed appropriately for the home and then installed in a quality fashion. And a builder can get credit for having their home HVAC graded through the HERS index process. Lighting and appliances, basically, do we have LED lighting in the homes, or is it CFL lighting, or do we have incandescent lighting? There's a difference in terms of efficiency of those different lighting systems, and so you can get credit on the HERS index for that. Appliances, do we have Energy Star appliances installed, or are they sort of federal minimum appliances? And we consider things like refrigerators, dishwashers, clothes washers, clothes dryers, ceiling fans. These are all, and then your cooking equipment, your oven or range. These are all considered as appliances within the HERS system. Of course, We consider the insulated building enclosure, the building envelope, all of the different surface areas that define that conditioned space of the home, our foundation walls, our slabs or frame floors, rim and band joists, above grade walls, windows and doors and ceilings, all of the geometry of those elements plus their relative R values, their thermal performance are all considered within the HERS index methodology. Finally, on-site power production is an option for those who are choosing to install on-site power, and choosing to install a solar panel array system or possibly a wind turbine system, possibly even some type of hydro energy. If you lived on a property that had a stream that was constantly running, you could potentially hook up a hydro power generator and generate on-site power production and quantify that in the HERS index. So the way that the process works for the HERS index is that builders contract with a certified home energy rater, otherwise known as HERS raters. HERS raters are credentialed through a standardized process that's dictated by the ResNet standards. They have to have training. They have to pass standardized examinations, and then they have to go through a probationary rater period in order to basically demonstrate their competency prior to going out and working with home builders. HERS raters can also have subordinate professionals working underneath them, such as rating field inspectors, who are basically professionals that are credentialed to do on-site testing and inspections, but they are not necessarily credentialed to do energy modeling. And then HERS modelers, who are professionals that perform energy modeling, but they're not certified to go out in the field and do inspections and testing. So oftentimes you as a builder may work with a HERS rater that has some of these other subordinate professionals working for them. So there really are two components of the rating process: a software process, software energy modeling. Again, all the square footage values and R values for your building enclosure, all your window areas and U factors and solar heating coefficients, the heating system, the cooling system, the water heating system, their distribution systems, lighting, appliances, air tightness, ventilation, on-site power production. All of this goes into quantifying the HERS index score in an energy model. Typically, it starts with a projected rating. A projected rating is an estimate. It's whatever you as the builder are saying you're intending to do. We can put that in the software to predict how the home is going to perform. That's not a final rating though, because we still, things change. A builder can say, I intend to put in R15 insulation in my walls, but then we show up and there's R13 installed. Why? Well, because that's what the installer had available, and so that's what they ended up installing. Or the intention was to put in a 90% efficient furnace, and it turns out a 95% efficient furnace was installed. So that's why we go out as raters and perform field verification, on-site inspections, and then also performance testing. Again, how airtight is the home? How tight are the duct systems? Is the ventilation system installed properly? These are things that we all perform in order to validate that process. Once all that inspection and testing has been performed, we finish the process by completing a confirmed rating. And that is the actual official HERS index score that is registered with ResNet as the oversight body for the HERS system. In between there is a quality assurance process. All raters have to work with a ResNet QA provider, and all homes are subject to quality assurance review. That can happen in real time, meaning like before the home gets registered, the quality assurance process will occur, or sometimes it happens shortly thereafter in order to validate that the rater is performing all of the necessary testing, inspections, and energy modeling appropriately. All of this ends up basically resulting in a series of reports. The home builder can receive reports from the rater about the performance of their home on the HERS index or energy load or consumption estimates. the builder could elect to pass that on to the consumer as something that they can use to advertise how energy efficient the home is. That's kind of how the rating process works. Again, all of this data goes into energy modeling software, Ecotrope being sort of the main one that is used by consumers and DTE Energy. Blower door testing. So blower door testing is a big part of field verification. We test how airtight the home is. And again, I would argue this is more important than ever before with how humid it was this summer, with Canadian wildfire smoke getting in our homes, fouling our air. I want an airtight home, darn it. And the blower door system is a tool. It's a large fan system that's installed in a doorway of the home. And based off of either the square footage of the building enclosure or the volume of the home, we can basically estimate how airtight it is. And that ends up going into energy modeling software as one of those values that can be used to impact the HERS index. Duct leakage testing, another one of the main things that we do as a company, or as an industry rather. So ducts can be tested for two different values. Duct leakage to outside is testing how much of the heated and cool air may be going into unconditioned spaces where ducks may live, like attics or crawl spaces or unconditioned basements or garages. And then there's a separate test called total duct leakage, and that quantifies just how tight are the ducts overall, be it inside conditioned space or outside. And that's useful more for just understanding how efficient the overall distribution of heated and cooled air is. And so oftentimes raters will perform both tests, although only leakage to outside is required to calculate the HERS index score. Ventilation testing, very critical element, and how we test depends on what system you have installed, and there's a variety of different tools that could be used. We're showing images of a hot wire anemometer, which might be used more typically for testing balanced or supply-based ventilation systems. Then up in the top right, we have a powered flow hood, which is a tool that is extremely accurate. Often could be used for testing either supply or exhaust-based measurements. It's very accurate in either direction. And then in the bottom right is a exhaust flow box device, relatively simple tool, mainly used for testing exhausts, although it may be appropriate also for some low flow supply measurements as well. Other parts of the field verification process, raters inspect insulation for its installation quality. So what that means is that you as a builder may say, I want R15 insulation in my walls, but that R15 could be installed perfect, just okay, or not so good. So there's grade 1, which is essentially a near perfect installation that fully fills the cavity side to side, front to back, top to bottom, with no voids where you can see the sheathing, as well as minimal compression, very minimal compression. Grade 2 allows for some amount of compression or incomplete fill, but it does not allow for gross voids in the cavity. And then grade 3 is less quality installed insulation. It's more beat up. And in particular, the most popular insulation product in the industry, fiberglass bat products, they tend to be a little bit more prone to defects. So that's why raters go up, because they want builders to get the value for their money. They want to make sure that their trades are being held accountable for installing insulation in a quality fashion, so that the builder gets their value and the consumer overall has better performing insulation over the life cycle of the home. We also inspect all the installed equipment. Again, things can change. HVAC can change. It turned out that the installer, you specified a 15 SEER air conditioner, but they only had a 13 SEER on the truck, and that's what they put in. Well, that changes the efficiency score. And again, it may not be what the builder paid for. Finally, HVAC grading, again, it's a relatively new process in the HERS industry, but it's become very popular with builders because, um, one of the main callbacks that a builder might get is that consumers don't feel comfortable in their homes because they don't feel that their air conditioning system or their heating system was properly designed or installed. So the HVAC grading system intends to cover basically all the key elements of a system design and then installation. So there's a design review to make sure that the system was appropriately designed prior to installation, meaning that the home had load calculations performed by manual J, that the system was selected for that load by manual S, and then the duct distribution system was designed by, typically manual D. And all of that documentation is reviewed by the rater prior to installation. The duct system is tested for tightness, again, total duct leakage tightness. The blower fan inside of the air handler is tested for its airflow performance. And then we can test the watt draw of the blower fan to see how efficient the distribution of that air is. And then finally, there can be an evaluation of refrigerant charge, principally for air conditioning systems. But if you're installing heat pumps, this is also very important because the heat pump is very sensitive to refrigerant charge in the heating system as well. So in particular in Michigan, if you're installing heat pumps, HVAC grading should just be a standard of practice because builders can get big time credit on the HERS index by pursuing HVAC grading, which is great for them. You essentially get credit as a builder just for making sure that your subs did what they're supposed to do anyways, which was properly design the system and then properly install it. So you get credit for something that essentially should have been done to begin with. And then in addition to that, the homeowner has the benefit of ensuring that their HVAC system is well designed, which will hopefully reduce the amount of callbacks that the builder or their subcontractors may experience due to consumer complaints. So the benefit of the HERS index ultimately is lower HERS index scores tend to portend lower energy bills. And by having a more airtight, well-insulated, good HVAC system type of home, people tend to be more comfortable and they may have better air quality, which will make them feel more at peace in their own home. Again, a lot of these features can and are being used within mortgage and appraisal evaluations. There's something called the residential green addendum that can be used in order to empower appraisers to value efficiency within the consideration within the appraisal process to make a home that's more energy efficient be able to qualify for a bigger sale price. That's a big advantage to a builder by basically, building with a HERS index score and then going through that residential green addendum process. So these are all very big benefits for homeowners. Homeowners, if you have more stable bills that are more predictable, then you can kind of plan for that in your budget and you're not going to have any big surprises. The problem with inefficient homes is when you have a mild year, no big deal. My bills are kind of low. I can deal with it. But if you have a summer like what we had this year, and it's hot and humid, and your home leaks, and you have poor windows and poor insulation, man, that's a hard one because your utility bills may be a lot higher. And then what happens if right after a bad summer, we also have a bad winter? And then you're really bumming as a homeowner because maybe you really can't afford those utility bills. That's the benefit of energy efficient homes as described by HERS index. More stability for the homeowner, more comfort for the homeowner, better air quality, and potentially higher home value. For builders, here, I would especially say here in the state of Michigan, there aren't there was only 5,000 homes in Michigan that got rated last year. There's a whole heck of a lot more that got built. So by you building with a HERS index and then advertising it, it can help you stand out in the marketplace. It can help convince consumers that your home is the one to select because it's been tested and verified to be an energy efficient home. You can also parlay that into things like energy code compliance or incentive programs, such as those offered through DTE and Consumers Energy. Marketing advantage, again, a way for you to stand out and get the credit that you deserve in the marketplace. And again, I've mentioned this issue of callbacks and warranty, having happy customers. We don't want homeowners to move in and then be uncomfortable, because then all of a sudden, as a builder, I got to go back and deal with that and fix it. And that may be time consuming and costly, or potentially even litigious. So the HERS index can really be a value proposition for the builder that goes beyond just whether or not I get a rebate or not. For policymakers or program implementers, think about communities or the state of Michigan. If we want to really prioritize where we're heading as an economy, or where we're heading in terms of an environment, using the HERS index can really help to promote, that long-term goal. So there's a lot of benefits. We're actually hearing from certain municipalities in the state of Michigan that they're actually looking to make HERS indices mandatory for certain types of buildings. Why? Because they're trying to plan a long-term future for their communities, and they know that energy efficiency and stability of bills is critical for their homeowners. Okay, so that's what the HERS index is and why there's some value. Now, here's how you can use the HERS index in order to strategize optimizing your home. So the cool thing, and this is, I cannot stress this enough, the best thing about the HERS index is that it is strategy neutral. You get credit in terms of energy efficiency for any approach that you choose to take as a builder. You're not penalized for potentially not having the most insulation in your home. That's okay. It's a factor within the index calculation, but guess what? You can make it up. You can make it up with installing energy efficient appliances, or better windows, or putting in better heating, cooling, water heating, and ventilation systems. Possibly you could even throw solar panels on the home and you get credit that way. So there's a lot of value to the HERS index because it doesn't penalize design. If you're a builder that already has plans that you have designed for you, and let's just say that they're designed with 2x4 walls, the cost for you to go and redesign your plans for, say, 2x6 walls could be significant. And you may not be ready to do that because you've been building with 2x4s for a long time. Guess what? Through the HERS index, that's perfectly fine. There's no penalty to having a 2x4 wall system, for example. Now, again, if you only have R13 or R11 or even R15, it's not going to look as good on the HERS index versus more insulation, but you can make that up with other strategies like HVAC rating, like appliances, like windows, like ventilation, etc. So these are, I guess, what I would say the main strategies that you could choose to take. And you could choose one or multiple of these strategies in order to get you to a better HERS score. So, I'm a big building envelope guy. I kind of just said you don't have to have a good building envelope, but the reality is I am a big building envelope guy. I think that having better insulation in buildings is a good thing. Why? Because people tend to be more comfortable. The temperatures tend to be more stable in a home. If there's ever a power outage, people might be able to maintain the heat in their home better. So I'm a fan of better building envelopes. I think it's a good thing. I think it's good for the grid and its stability over time. So that's a strategy. So better insulation on your walls, on your ceiling or roof, foundation walls, slabs or floors, all those things can and are considered as part of the HERS index. Windows. Well, again, maybe I don't necessarily want to invest in better insulation on my walls. I think R13 is good enough, but you might consider better windows. You could put in Energy Star windows, or at least better than code windows, and that will buy you some effort on the HERS index. It will help to lower your score through choosing better window products. And it may not cost as much as redesigning the home, possibly. High efficiency HVAC systems. Again, here in Michigan, I don't want to overly generalize, but I think that most people are putting in 90+% efficient furnaces. We're using gas or propane. That's great. But what happens if we're doing heat pumps? What happens if we have AC? We might want to consider putting in higher efficiency products and then evaluating it using HVAC grading. Having an airtight home. Again, I cannot stress how critical this is of something we should all be considering, because I don't want to breathe wildfire smoke. I have a brand new daughter. I don't want her to be breathing wildfire smoke. And if my home leaks, even if I have all the windows and doors shut, that foul air has a chance to get in my home, and I don't want to breathe it. So having an airtight home with then good quality ventilation so that we can still breathe and that we're reducing moisture potentially in the home, that is the 1-2 punch, the peanut butter and jelly of success for having better resilience to the home, better comfort, and better air quality. It's kind of one of the most critical things. Energy Star appliances and lighting, or just high efficiency lighting and appliances, definitely a value that you get in the HERS Index method. And then finally, you can throw solar or another form of on-site power production on the house if you choose to. So just talking through what these are, again, building enclosure, that is the insulated building structure. We're showing walls here, and we got 3 different strategies. On the far right side, we have a blown-in system. It looks like a blown-in fiberglass system. The benefit of blown-in fiberglass is that it more easily fills a cavity top to bottom, side to side, front to back without major variation. I like the blown-in fiberglass system or blown cellulose for the same reason, because it tends to be easier to get a really good quality installation. We see in that wall that there's wires going through the wall. We can see that there's utility boxes that are going through that wall cavity. The challenge with a bat product, be it fiberglass or mineral wool or another bat product, is you have to splice around those and you have to fit them in the cavity, again, side to side, front to back, top to bottom, without a lot of compression or other variations in order to get the full rated R value. It can be done. You can get grade 1 with any bat product, but it takes a little bit more meticulous effort and focus. The middle photo shows a blown spray foam application. Foam, I think, is another really great application. It can fill the cavity top to bottom, front to back, side to side with no compression or very little. You got to be careful about pockets. You got to be careful about, where, maybe the curing of the foam wasn't perfect. You can still do foam not that great, either because of, the chemistry or somebody just underblows it. So you got to be careful of foam. It's not a guarantee that you're going to get a great wall, but there's a good option there. And then in the far left, we've got a home with continuous insulation. So this may be a home with 2x4 walls or 2x6 walls, but it has continuous insulation through foam board on the outside of the home that, again, just, it makes the home that much more comfortable. It's kind of like we're building like an igloo, cooler, or, a Yeti cooler. Why do Yeti coolers work so well? Well, because they're really well insulated and because they're airtight. That's why your beverages stay so cold for so long. So the benefit of a better building enclosure, lower heating and cooling loads, basically, higher R values, and it can help to lower the score. And it can also basically improve comfort and durability. And I'm not going to get into nerdy physics here, but long story short, when you have better insulated building systems, there's less of a feeling that the surface temperatures of our building are potentially cold or uncomfortable, which can be an issue. And think about the deep cold. We can get very cold here in the state of Michigan, and if we have poorly insulated building enclosure, that can feel uncomfortable because our bodies can sense the temperature of the surfaces around us. All right. I lied. I'm going to be a nerd about it. It's called mean radiant temperature. Go look it up if you don't know too much about it. We talked about it in a previous episode, and go watch that if you desire to. Other things that go into, better building enclosures, advanced framing. So you can build walls better, just a standard stick frame wall, you can build it better through advanced framing. Things like having 24-inch on center framing instead of 16-inch on center. Things like insulated corners, insulated headers, ladder T intersections, less superfluous framing. To me, this is just smart building. Lumber is expensive. Why not optimize our framing package? You can get credit on the HERS index. Sealed and conditioned attics and crawl spaces. Again, this could be an option. We don't have a ton of crawl spaces in Michigan, but where we do, man, would I rather have a nice, clean looking crawl space that's insulated on the foundation walls, maybe on the floor, nice, clean vapor retarder on the ground, insulated ductwork, so that I could go down that crawl space and not be totally grossed out like an old school vented crawl space with spiders and rodents and insulation hanging down all over the place. Man, that's nasty. Same thing for attics. If we spray foam at the top of our roof system, we can cut down on air leakage, cut down on heat loss. If we have duct work up in that space, it will, basically any losses off that duct will just happen here within the home itself. So it helps to cut down on energy bills as well. So, again, benefits here, reduced air infiltration, keeping ducts with inside conditioned space, lowering heating and cooling loads, and, potentially reducing moisture and making the home more durable. These are all benefits of considering sealing and conditioning things like attics and crawl spaces. And you can really gain benefit on the HERS index by doing so. By going for all these things, there's a big benefit for more airtight, more comfortable homes in that regard. Say you're not a big building envelope guy, you just for whatever reason you've been insulating the home the same way for decades, and you don't necessarily feel like changing that. You can basically build the exact same home, the exact same framing system, the exact same framing depth, vented attics, vented crawl spaces. You can do the exact same thing you've always done, including the exact same windows in the same location, but just improve the windows. You can optimize SHGC. And guess what? In our climate, a modestly higher SHGC tends to work out better for us. Why? Because we're not a super, when we deal with air conditioning here in Michigan, it's usually because of humidity, not because of temperature. We didn't break 100 for the most part this year. We rarely do. Yeah, we had some days over 90, but the reality is if our air conditioner was running this year, it was mainly because of humidity, not because of temperature. And so bringing in more solar gain in the wintertime to help provide free heat is a good strategy. Multiple panes of glass. So considering, better double pane or triple pane glass. And then some other things like, good overhangs can all go into making better benefits, passive heating and cooling, a better overall thermal performance of our wall, and potentially reducing air leakage. Energy Star windows are a good way to go about specifying your windows, because you know that you're going to get a good one if you go that way, and they're not necessarily that much more expensive than just a standard code built window. So I would recommend going to check out. There's different options for getting to Energy Star here in the northern climate. We talked a lot about those in the Windows lesson, which I would refer you back to. Better HVAC equipment, whether it's a gas or propane furnace or a heat pump. Either way, going for better equipment is going to lower people's bills, but we got to make sure it's designed and installed properly. So again, I think that HVAC grading part is a really important element, because we're then not just saying whatever the nameplate is, but we're actually quantifying just how well installed and airtight and well distributed that heating and cooled air is. So highly recommend, if you're a builder doing a HERS index, that you go through getting an HVAC grading performed. Air tightness, I just think, is the most important thing. I want an airtight home. I don't want to breathe Canadian wildfire smoke. I don't want humidity coming in my home. It's a no-brainer. People for the longest time say, well, homes have to breathe. Wrong. Humans have to breathe inside the home. We need good air quality. Homes need to make sure that they are ventilated to reduce moisture, which can be damaging to a building enclosure. So when people say homes need to breathe, what they're really saying is we don't want moisture to get locked in the home and start to cause mold and degradation. That's 100% correct, but we can achieve that with an airtight home with properly designed and tested mechanical ventilation. I think this is just more important than ever. And as a builder, if you're savvy, you can sell this. You're not going to have to deal with Canadian wildfire smoke. You're not going to have to deal with bugs or humidity getting into your home. And with a good ventilation system, I can show you there are consumer grade apps and monitoring systems that will show good air quality. And you can show a homeowner your home has superior air quality because it's an airtight home. Highly recommended. Again, on-site power production is an option, whether it be solar PV, wind generation, hydroelectricity. We've got a solar thermal system on here that's mainly for hot water system, but again, free energy from the sun, and that can be used in order to reduce your HERS index. Lights and appliances, they're kind of a no-brainer. Not every builder provides appliances, but if you do, specifying energy efficient ones such as Energy Star appliances can help to lower the HERS index score. Again, DTE and Consumers Energy, they have some great programs here to incentivize people to get a HERS index done. And guess what? You don't need to have a crazy efficient home or a very expensive home in order to get in the door with Consumers and DTE Energy. The incentives start at a 59 for consumers and a 60 for DTE. Looking at this chart, if we are not Energy Star under consumers, basically, our incentives can range from 75 all the way to $1,000 per home, depending on what consumers is providing to the home, be it electric service or gas service or a combination. If you do Energy Star, you can get up to $4,000 per home. So you can get some decent money back from the utilities just by end up getting a HERS index that qualifies. From consumers, it's a little bit more nuanced in terms of how the incentive works. But again, those incentives, if you're just getting a HERS index, it can range from 1,300 all the way up, 1,300 all the way to 2,100. But if you actually have a 45 on the index or less and a cold climate heat pump, you can get $3,500 back from the utility. And then there's bonus incentives for Energy Star certification. Again, it's a little bit more nuanced about how this is calculated. I encourage you to talk to the program managers at DTE and Consumers if you need more information on the incentives. Other thing, just to stress about the HERS index and energy efficient homes, long-term savings, higher appraisal values, saving money over time, potentially having lower maintenance because you have a better quality home with increased durability. Here's an example here in optimizing a home using the HERS index. So the reference case is 100, and this is the Smith family home being built in climate zone 5. What score do we go with? Well, for a reference home, it's R38, not great ducts, and the windows are kind of just okay, and it's got an old 78% gas furnace with inefficient lighting. So if we go for R49 in the attic, sealed ducts, decent windows, these are just kind of like almost just a little bit better than code windows, and then a mini split heat pump and Energy Star lighting and appliances, we can get to a HERS score of a 52. So, our savings is projected to be about $1,300 a year. That payback is 16 years. Well, guess what? This home is going to be there for 30 plus years. And so there's a lot of value to investing in these features here for the Smith residents. Beyond HERS, you can get involved with above code programs like Energy Star, Lead for Homes, DOE Zero Energy Rating homes and the National Green Building Standard, NGBS. And the HERS Index is just a component of that. So, some other misrepresentation, HERS score is always more expensive. Not always. Air sealing and LEDs are low cost but high impact. Only green builders get their homes rated. Not true. Any builder can have their homes rated, and many of the national home builders rate every single home. So, the big boys are doing it because they know that there's value. It's just for eco-conscious homeowners. No, I mean, this can be for people who just want a better home. I don't care if you're a liberal or a conservative. Everybody wants a better home, a more comfortable home, and nobody is angry about saving money. Ultimately, the HERS Index, it's a simple way to get good data and help the homeowner get a better home in the long run, and it can help the builder really sell a better building as well. So to me, it's a no-brainer to use the HERS Index as an optimization tool. Coming up next week, we've got above code HERS Index as a design strategy, kind of like taking this same presentation, but to the next level about how to use the HERS Index to help build your better home. We'll see you next week. Talk to you then. Have a happy holiday.